All right, you guys, let's continue our discussion of property of logs. Let's look at our next example. So it says, write the natural log of x squared over x minus 1 cubed, where x has to be greater than 1, as a difference of logarithms. Express all powers as factors. Okay, so the first thing I'm going to do is write our problem. Oops, natural log. Okay, so remember, the first thing you want to do is recognize which operations are in the argument of your log. Okay, so as I'm looking at this argument, okay, the major operation that I see is division. Okay, so anytime that you are dividing logs, okay, dividing can be expanded by using subtraction. Okay, so that subtraction is going to occur where the division happens, and you're always going to do it numerator divided by denominator. So this is going to equal the natural log of x squared. Instead of dividing, subtract the natural log of x minus 1 cubed. Okay, and then I like to fix each expression one by one so I don't forget everything. So I'm going to look at this first expression. Okay, so in the argument of that log, I'm going to see, do I see any multiplication? Do I see any division? Or do I see any powers? Well, I don't see any multiplication and I don't see any division, but I do see an exponent, that 2. So that 2 needs to come to the front by our rules of logs. Okay, so that's going to give me 2 natural log of x. Now, as I look in that expression again, I no longer see any multiplication, I don't see any division, and I don't see any powers. So that one's complete. Okay, now let's look at the second one. So I'm looking at this argument. Okay, I'm looking to see, do I see any multiplication, do I see any division, or do I see any powers? Well, I do see a power. I see this 3. So the 3 is going to come in front of the log. Okay, so I'm going to write that. So I'm going to have minus 3 natural log of x minus 1. Okay, and then I'm going to look in that argument and see if I see any multiplication, any division, or any exponents. I don't have either of those, so I've completely expanded my answer. So we're done. All right, let's look at another problem. All right, this one says, write log base a of the square root of x squared plus 1 over x cubed times x plus 1 to the 4th power as a sum and difference of logs, and express all powers as factors. Okay, so just like before, the first thing I'm going to do is write out my problem. Okay, so I'm going to look at the argument and I'm going to try to identify any major operations that I see. Okay, so the overall operation that I see is division. Okay, so remember, when you are dividing gets expanded by subtraction. Okay, so where that division is, I'm going to break it out by using subtraction. So it's going to give me log base a of the square root of x squared plus 1 minus log base a of x cubed times x plus 1. Let's move this over to the 4th power. Okay, now remember, I like to fix each expression one by one so I don't get confused. All right, so in that argument of that first expression, okay, I'm looking for any multiplication, any division, or any powers. Okay, well, I don't see any multiplication or division, and I don't see any powers, but what I do see is that square root. Okay, and square roots cannot remain in the argument of a log. So the square root of x can be converted to x to the 1/2 power by using a rational exponent. So I'm going to rewrite that expression using a rational exponent. Okay. Now as I look at it, I see that there's an exponent there. So by our rule of logs, exponents can come to the front of our expression. So that's going to give me 1/2 log base A of x squared plus 1. Okay. Now that expression is completely expanded. There's no more multiplication, there's no more division, and there's no more powers. So that one's okay. Now I need to fix the second one. So in the second one, I'm going to bring this down for us. Okay, so we have minus log base A, x cubed, x plus 1 to the 4th power. Okay, so the major operation that I see in that argument happens to be multiplication. I have x cubed times x plus 1 to the 4th. So anytime that you have multiplication, multiplication gets expanded using addition. Okay, so when you multiply, that gets expanded by addition. Okay, so where that multiplication occurs, I'm going to expand it using addition. So this first part remains the same, the expression that we've already fixed. Okay, I have minus. Now I'm going to put a bracket here. The reason why I put a bracket is because this expression follows a minus sign. So once I'm done completely expanding it, I have to remember to distribute that negative sign to everything that's going to come behind it. Okay, so I'm going to have log base A of x cubed plus log base A of x plus 1 to the 4th power. Okay. Now, in each one of those arguments, I'm following the same steps. I'm looking to see, do I see any multiplication? Do I see any division? Or do I see any powers? Okay. Now, in both of those expressions, there's no more multiplication or division, but they each have an exponent. So those exponents are going to come to the front of each one of those expressions. Okay. So I'm going to rewrite our problem. Okay. Now, in each one of those arguments, everything has been completely expanded. The only thing we need to remember to do is to distribute that negative sign, okay, to the terms that follow it. So to this expression and to the second one. So our final answer will be this. Okay, and you've completely expanded that log. Great.